Hey there, and welcome to this explainer. Have you ever wondered exactly what goes on behind the scenes when your internet connection just suddenly drops out of nowhere? Or what technicians are actually doing when a massive cell tower goes completely dark? Well, today we're unpacking a comprehensive fault guide. We're going to step right into the shoes of the engineers who diagnose the invisible infrastructure powering our digital lives. Let's get started.
Okay, let's dive into this. When the internet goes down, human nature usually makes us point fingers and blame the service provider right away, right? But I was absolutely shocked to learn that a massive 70% of network issues are actually just our own home router problems. Only about 30% of the time is there a genuine physical fault within the broader network infrastructure. To understand how these things are actually fixed, we're going on a scale of impact journey today. We'll start at the customer's home network, move on up to fiber cables and patching, zoom out to cell tower emergencies, and finally tackle major regional outages and the network operations center. All right, so starting right at the source, Section 1, the customer's home network. This is our first and most localized level of troubleshooting.
So, the absolute crucial first step is determining whether the problem is actually the internet provider or if it's just the Wi-Fi inside the house acting up. A Wi-Fi test can be totally skewed just because your router is shoved behind a thick TV or, fighting for signal with your smart fridge. But a wired test, where you plug a network cable directly from the router into a laptop, well, that bypasses all of that noise. If the wired test works flawlessly, it definitively proves the provider's network is perfect, and the issue is purely local. Once we actually know it's a Wi-Fi issue, the fixes are surprisingly simple. First off, let the router breathe a little. Move it out of that closed cabinet into an open area so the signal can actually travel. Second, just restart the router. This drops idle devices like smart TVs or old tablets that might be silently hogging all your bandwidth. And finally, on your phone or laptop, just use that forget and rejoin network feature to give the connection a clean slate. But what about your mobile phone? We've all looked down at our screen and asked this incredibly frustrating question. Why do I have only 1 bar of mobile signal right now? To troubleshoot this at the customer level, we really have to look at the environment. If your signal is perfectly fine outside but terrible the second you walk inside, the culprit is often thick building walls or tinted windows physically blocking the radio waves. Other times, maybe the phone's network mode isn't set to auto, or worse, a neighbor might be using an illegal signal booster that's just blasting invisible interference everywhere. Since a network provider obviously can't just drop a new multi-million-dollar cell tower in your backyard to bypass the thick wall, your absolute best immediate fix is simply toggling on the Wi-Fi calling feature on your device. It's a real game changer. Moving one step out, we hit Section 2, fiber cables and patching. Now we're looking at the physical lines connecting our entire neighborhoods. When a customer loses signal entirely, the hunt for the actual physical damage begins. Now, I hadn't fully realized this before, but fiber optic cables are literally made of thin glass. They do not stretch. If a pet bites it or a heavy couch crushes it, it just snaps. So technicians first look for these tight bends, which they call kinks. Then they use an optical power meter. If this meter detects absolutely zero light, it means the break is somewhere between the house and the street. And since you obviously cannot use tape or super glue to fix broken glass, they have to either replace the entire patch cord or use highly specialized splicing tools to actually fuse the glass back together. Now I need you to listen closely because this next part is a critical safety rule. Never look into a broken fiber. When a fiber cable snaps, it leaks invisible laser light, and because it operates completely outside the visible spectrum, your eye won't instinctively blink to protect itself. That invisible laser can cause severe, permanent eye damage. It is a massive, serious safety hazard for technicians out in the field. Now, what's really interesting about this slide is how they solve a purely human error, like wrong patching, using actual lasers. Imagine a technician accidentally plugs a customer's cable into the wrong port at the street cabinet. The line is technically active, but the customer just gets an authentication failed error because they're being routed to the wrong account. To fix this, technicians first verify the cable labels, but, labels can be wrong. So they connect a special laser pen called a VFL to the cable inside the customer's apartment. Then they walk all the way out to the street distribution box and simply look for the specific port that is glowing bright red. That visual cue traces the exact path, allowing them to quickly move the cable to the correct port. And speaking of those street cabinets, here is another absolutely vital protocol. Never unplug cables blindly based on old labels. If a technician just guesses and unplugs a line, they might accidentally take a local hospital or a major business completely offline without warning. Verification is literally everything here. We are zooming out to the macro level now. Section 3, Cell Tower Emergencies. This is where a single isolated failure can drop service for thousands of users all at once.
When a massive mobile tower completely loses main grid power, it is essentially running on borrowed time. The site automatically switches to backup batteries, and the clock immediately starts ticking. First, the technician has to call the Network Operations Center, the NOC, to confirm if it's a total blackout in the area or just a single failed module at that site. Next, they inspect the entire power chain, checking the main electricity meter, trip circuit breakers, and the power converters. Finally, they test the battery voltage to calculate a literal countdown, exactly how much time is left before the tower dies and drops thousands of active calls.
And because these towers require massive amounts of electricity to broadcast signals across miles of terrain, diagnosing a power chain is incredibly dangerous. High voltage is a lethal hazard. There are no second chances. Technicians are strictly required to always wear insulated safety gloves and protective glasses whenever they're working inside these power cabinets. Strangely enough, I learned that sometimes a power alarm isn't power at all. Actually, scratch that. It's a heat emergency. High heat will literally cook sensitive electronics. If the air conditioning fails inside a sealed tower equipment room, it becomes a desperate race against the thermometer. Technicians will immediately throw open the heavy doors for emergency ventilation. Then they'll systematically check the AC breakers, look for clogged air filters or water leaks, and verify that the tiny internal fans inside the telecom equipment are actually spinning. Finally, they use a handheld digital thermometer to test the room sensor, just to make totally sure the equipment isn't giving a false panic alarm. And that brings us to the top of our scale, Section 4, Major Outages and the NOC. We are now dealing with regional infrastructure control. A backhaul down alarm is massive. It basically means the tower's main pipe to the internet is entirely cut off. Absolutely no data can pass through at all. To diagnose this, the technician first checks the physical port light to ensure the cable itself isn't severed. Then they check the transmission media. They have to verify if maybe a severe storm blew the microwave transmission dish out of alignment on the roof, or if the fiber optic modules have simply gone dark. Crucially, step 3 is calling the NOC to ask if neighboring sites are also down. If they are, well, it's not just a single tower issue anymore. It's a massive regional outage. Throughout this whole process, the field technicians basically act as the hands and eyes for the Network Operations Center. When the NOC detects an error from afar, the technician on site has to verify that the physical LED warning lights on the actual machines perfectly match what the digital screens are showing back at headquarters. They'll dig into the system history logs, looking for subtle triggers, like maybe a split-second power flicker. And here's the thing, a repair is never considered truly finished until the technician verbally confirms with headquarters that the glowing red alarm on the master dashboard has finally, officially turned green. And this brilliantly illustrates two drastically different network realities. Planned work is deeply controlled. It's scheduled maintenance done in the dead of night, usually between 2 and 5 a.m. when everyone's asleep. Customers are warned well in advance, and engineers always arrive with a strict rollback plan to undo their changes if things go sideways. An unplanned outage, however, is pure chaos. It's a sudden, high-stress accident, like a construction crew blindly cutting a major underground cable or a massive grid power drop. There is absolutely no warning. The sole goal in that moment is minimizing the MTTR, or mean time to repair, getting the whole system back online as fast as humanly possible. As we wrap up this explainer, we can really see the incredible journey we've taken up the scale of impact. From a single bent cable ruining your living room movie night, all the way up to a regional power drop silencing thousands of phones in an instant, the solution is always exactly the same: structured diagnostics. A calm, step-by-step, methodical approach is what truly keeps the world's data flowing. So, I want to leave you with this final thought to ponder. Knowing what you know now about fragile glass fibers, laser routing, taking battery backups, and emergency cooling fans, how many invisible layers of safety, fiber, and infrastructure had to work flawlessly right at this very second just for you to watch this explainer today? Thanks for learning with me, and I'll catch you on the next deep dive.